Okay, so here we have the circle, and the circle, it's very simple, very simple. Um, all we're doing is, well, for this, all we're doing is we're getting the radius. So this is our standard formula: x squared plus y squared equals r squared. Now all we're doing is we're putting it in its standard formula. They're gonna give us a radius. They might like this is just introductory, but they're gonna give us a radius, and we must put it in the standard form. So how we do that is the radius is r. So r equals to 3. R equal to 3. And all we do is we substitute that 3 into r over here. Substitute, we get the number 3 to the power 2 is 9. You just write x squared plus y squared equals r squared. X squared plus y squared equals 3 squared. X squared plus y squared equals 9. Straightforward, you're finished. Next one is the same thing. The radius equals square root 3. So r equals square root 3. You put it in, you just substitute it in. You substitute it in, you get the answer, you're finished. Yeah, they will give you the radius. They will give you the radius. Actually, I haven't seen a question on circles in the exams for quite a while now. They normally give you a parabola or a straight line, or maybe a circle and a tangent, but they never really ask you circles for a while that I've seen. Oh, but someone said in the group actually questions. Okay, maybe we can do that tonight. I think it was Bradley Williams. Bradley, you saying that. Okay. Anyways, so the next one, they give you a point. They give you maybe a point on that circle. All right. They say that point 2 or 5 or 2 and 5 is on the circle. So we know that 2 on a coordinate, this 2 here is the x, and then that 5 is the y. All we do, we substitute that 2 in the x, this 5 in the y. We simplify, I guess. We simplify, we add it. So r squared equals 29. R squared equals 29, right? That r squared, it's in our standard formula. So all we do, we write 29 as is, because 29 equals r squared. That's all we do. Okay? Again here, we have another point on the circle. So this -2 is our x value, and that 1 is our y value. What we do now, we substitute -2 in our x, 1 in our y, we add, we get the number 5 equals r squared in our standard formula. We write it as is. Then we are finished. Then we are finished. Very straightforward. So this next one, the next one is saying calculate the equation of a tangent to the circle x squared plus y squared equals 25 at 3 and 4 on the circle. What does this mean? This means that we have, okay, you guys can't see the pens almost, né? Let me use, I'll use the red pen. So here we have our graph, right? We have our graph. Then we have a circle. Then we have a circle. Let us say, then they're saying at 3, positive 3, it's there. Let's say it's there. So here is our 4, that's our 3, right? Then they are saying that there is a tangent to our circle, meaning there is a line that passes through this point on the circle, right? At this point here, at this coordinate here. Okay, so again, this 3 is our x value, and this 4 is our y value. We are given our r squared as 25. So r squared is 25. Our 3 is our x, and our 4 is our y. This is our standard formula for the tangent. X1 times x plus y1 times y equals r squared. So all we do, we write our standard formula down. Always start with the formula. Then we just substitute. Very straightforward. We substitute for our x1. We substitute for our y1. Then we now know. So they asked us for the equation. How do I write this now? For the equation of the tangent. A tangent is a straight line, right? So we need the formula of a straight line. What they're asking. Equation of a tangent is the formula of a straight line. Okay, that's what they're asking us. And we now know that because of yesterday, the formula for a straight line is y equals to mx plus c. Y equals mx plus c. When they say equation of a tangent, they mean the formula of a straight line. Okay, so yeah, all we do, we substitute our x, our y, then we basically solving for y. We're getting y alone. So we take this 3x over to the other side, then automatically um, we divide with our 4, then technically speaking, right? Um, this 3 over 4 we know is um, our m value. We know that this 25 over 4 is our c value. But what I didn't tell you guys yesterday was that, so yeah, you know that m is our gradient, right? M is our gradient. What is c? Does anyone know what our c value is? Yes. So y-intercept. That just means that this line passes through our y-axis at 25 over 4. That's all what it means. That's all what it's saying. Okay. Then over here we have writing from standard form. Basically, it is we are converting. It's actually called this, yeah. It is converting standard form to intercept form. That, oh, you can't see. Yeah. That's all what it's saying. Converting from standard form being our y equals to mx plus c. From that form, we must have x, how do I write this now? X over something plus y over something equals to 1 to intercept form. Okay, how do we do this? So we are given a formula. We are given this formula over here. We are given this formula. So we need y and x basically free. We need both of them free from any number that's attached to it in any way. If it's in a fraction, we want a fraction, but if it's like this multiplied, we don't want it. So what we do is we multiply with a 3. Multiply with a 3 to get rid of this 2 over 3 here. Then we do that. Then we divide with 12 to get this to 1 because we want this also to be 1. The number here should be 1 also. So we divide with 12. This can be any number, but it must become a 1. So we must divide with that number. So here we get over 12, and that should also be over 12. Then all I did here, it is to simplify. So here we simplify. We're simplifying. So I put x first because normally we put x first, like like for the circle, x is first and then it's y. So this is just the proper way to write it, to put x first. Very straightforward, but they rarely ask this. This is like for exam purposes only. Like rarely do they ask you this for an exam that I've seen. But definitely we'll do more of this. Is everyone okay with this page so far? Like this page here. Is everyone okay so far? If anyone wants me to repeat something, you can ask me. If not, yes, that's the standard form for intercept formula. For intercept form, yeah. You will see that in others, there's more examples. I think there's one more example that has intercept form for the worker to come now. Now we're gonna see that work now. Now it's equal to 1. That's just intercept form. In math, there's weird things in math. Okay. Then here we have a few graphs. Have a few graphs. On the other side, okay. Okay. So here we have a few graphs. So we now know that could we could everyone please mute, until you have a question so don't have any extra noise. By donkey. Okay. So we know that this is now intercept form, alright? This is intercept form. And We know that intercept form it's working with the straight line formula. So this is a straight line. We know this is a straight line because there's no squared. There's nothing. We x is under the graph, nothing. So we know that this is straight line formula, and this is just shortcuts, right? That I'm showing you now. But there's ways to determine all these things, and very straightforward. All we're gonna do is we are going to literally just substitute 3 is what x in the same fraction, so it's on the x-intercept. It's on the x-axis. Y over 4 has a negative here in front, so it's going to be under the graph, and 4 is what y, so we just put 4 on the y-axis. If we, I believe if we make y 0 to get x, we'll get the same answer. Will we? Or we get the same answer, I wonder. But this is shortcut method. This is no thinking involved. All you do, you take that x over 3, it has a 3, you put the 3 on the x-axis. Y over 4, it has a 4, and the sign, it's negative. So it's going to be under the graph, and you write the 4. Yeah, yes. Draw the graph. They will ask to draw the graph. Yeah. You see, because this is intercept form, right? Intercept form. So 3 is on the x-intercept, and 4 is on the y-intercept, and it's negative. It's negative 4. It's negative y over 4. That is why it's intercept form. It's points. Intercept is points, right, on the graph. That's why you can substitute it just like this in. Just plot it just like that. No thinking involved, no thinking needed, nothing. Okay. The next one, number 2, it is a parabola. And we now know how to solve this. So to plot this graph, we need two things. We need the x-intercepts. Okay, actually three things. It's, but we can say it's 3. So it's x-intercepts, y-intercept, and does anyone know the last one? Turning point. Correct. Turning point. For all parabolas, no matter what graph is, what they say in the thing, you need these three things. Sometimes a parabola doesn't have a y-intercept, like this one over here. There's no y-intercept. It's passing to the origin because of where the x-intercept is sitting. But okay, we need these three things, and we start by x-intercepts. We start by that first. We start by that first step, the first one. Okay, x-intercepts. X-intercepts. You say y equal to 0. Basically solving x, right? We all know this by now. We factorized, took the common factor. So we did, took a common factor out of x. and x minus 3 was our factors. X equal to 0 and x equal to 3. That's our x-intercepts. So we plot that points first. So we have 0 and we have our 3, right? Now to get our turning point, our turning point needs a few things also. It needs the axis of symmetry, and it also needs that y value. Alright? This y value comes from substituting the axis of symmetry into the given formula. I'm gonna put it like this. Our axis of symmetry is our x value. Just so you guys know. Okay? So here we have it. The bottom, this is our axis of symmetry. So our axis of symmetry formula, it is minus b over 2a. Our b value is negative 3. So we substitute it. That's all we do. We substitute. We get the answer of 3 over 2. 3 over 2 is it's 1 comma 5 also. This is x equals, right? X equal to that. So all we do now is we take our x value and we substitute it into the given formula. So y equals 1 comma 5 squared minus 3 1 comma 5 equals to negative 9 over 5. So this x value, our 1 comma 5 or 3 over 2, it's our axis of symmetry, meaning our middle, our x value, which is 3 over 2, which is 3 over 2. It's this point over there, that point over there. Our y value, our corresponding y value, it's negative 9 over 5. But we should know this by now, right? We should. So the next one is telling us, it's also a parabola. So, so the only difference is that this one is a positive parabola, a positive graph, and this one is a negative, and this one is a negative. Only difference, but the exact same steps follow. First thing we do, we get the x-intercepts. We set y equal to 0. We factorize. We get our answer. Let's put here. Factorize. Factorize. And we factorize here. We factorize over there. We get our x values. Then we do axis of symmetry. We do axis of symmetry. We get our x value. We substitute our x value into our y value. We know it into our given equation. So this is our x value. This is our given equation. This is our y value. Okay, so working backwards now. Our x-intercepts we got as negative 5 and 2. So we plot our points, -5 and 2 is our x-intercepts. Then for axisymmetry, our x value is -3/2. So we find -3/2, -3/2 is there. Then we go up. Then our y value, it is 12,25. So we write 12,25. We plot our point. We plot our point. We plot these points first. This one also we plot it. Then we can draw our line, our curve. Then we must write this is our y-axis and this is our x-axis. Always write the y and x-axis, very important. Okay, maybe one more. Straightforward, right? Straightforward. So the next ones, let us focus on. Oh, do I have? Let me just get this view. Okay, this next one is also parabolas, right? It's also parabola. Number 4 now, it's a parabola also, but there's no bx plus c. The bx plus c does not exist for this one over here. And as you can see that there is, we still x now. Here's the x. Here's the x. But how we do this one is very straightforward. So if they ever ask you a graph like this, we again have a shortcut. We do the shortcut. So we have our graph. We have our graph. We plot 1. Always there's gonna be a 1. 1, right? And the given is a positive 2y. Positive 2y squared. So it's a 2. We plot the 2. We plot this 2. So all we're really doing is we're plotting these points, but we don't really use it. But we kind of do use it. Another graph is supposed to be, right? It's supposed to be this. Don't draw very nicely, but this is all it is doing. Basically, this one is like a boundary line that this graph doesn't really pass. Alright. This two just gives the shape. That's all it really does. It gives some shape. Doesn't really do much. Okay. But doesn't matter how you draw it. Just put that one, and whenever they give you over here, you put it down on the x-axis, right? Because this is what x now. Working with x. Then for this one, the exact same thing, but as you can see, it's a -1/3y squared. So we plot our 1 again. We plot our 1, our -1/3. See, it's on the x-axis, so it's on the negative side, 1/3. So we just draw in. We just draw in like that. Very straightforward. You just plot the point they give you, 1 over 3, negative 1 over 3 on the x-axis. On the y-axis, all you do is you plot 1. You plot 1. All you do. For number 6. So will it always be 1? Yes. Yes, always. But that's but for strange reasons, I don't know why, but they never ask because it's so simple, right? It's so simple to draw this. They never ask it. They would normally ask maybe something like this. They would ask this parabolous straight line. They will ask circle with a tangent. They will ask like we did a circle and a tangent last night, but they never really ask these easy ones. They never ask. They ask half circle and maybe ellipse. They ask, but I've never seen this one. But okay. This one is quite similar actually. Um, but the numbers don't matter for number 6 and 7. All you must look at, let's say they give it to you x, y, and 4. X, y equal to 4. All you do is you you solve for y basically. So you divide with x. So you have y equal to 4 over x, which is hyperbola, right? This is hyperbola. So hyperbola is positive because it's a positive 4 over x. So we write it like this. Again, this 4 and this 1 doesn't really mean much. Doesn't mean much at all. Don't even use it. The important thing is the sign, knowing where to put hyperbola. Okay? Number 7, it's a same thing. Xy divided with x, you get a negative 6 over x. So the hyperbola is negative, so it's going to be in this quadrant and this quadrant over there. This meeting will end in 15 minutes. So by yeah, we can't leave it, but okay. In 15 minutes, it's gonna cut out. Then we just join again, guys. Ne? You know now the story. Any questions on this? Very straightforward, right? 6 and 7, you just draw on based on the sign. Number 4 and 5, you plot your 1 and what they give you on the x-axis, you draw. All you do. Nothing. So 6 and 7, you don't have to plot it. Quadrant. Yeah. All you do. Okay. Yeah. Yeah, of course. I can also send pictures afterwards for you guys. No problem. Yeah. Yeah, I know what. Yesterday's one, I sent the video this morning. Well, okay, I'm gonna send it now again over there. But okay, we have some more graphs, and the next one is a circle. I'm gonna show you now. So the question is right to plot and draw. They give you an equation. They're gonna say plot and draw. All we do is we plot and draw. Okay. So they give us x squared plus y squared equals 9. So all we do, we say square root 9. Square root 9. Square root 9 equals to 3. So the radius of our circle is 3. So we plot 3 all around our graph. We plot 3, we plot 3, we plot 3. It's negative 3 here, right? It's positive. It's negative 3 over here. It's positive 3. It's positive 3. Then we draw a circle. Straightforward. Number 9. Square root 2. We plot our square root. The square root 2, it's square root 2. You know, it can't be simplified more than that. So our radius of a circle will be square root 2. And also, these circles, these circles are at the origin of the circle. So it is starting at the origin of the circle. Okay? So, yeah, exercise. There's no exercise, meneer. Yeah. This examples that I had. But just I'm gonna send this video again, and I will try to find questions if I can. Maybe you guys can do a question. Maybe you guys can do questions with me. I have two more here. Okay, but I can make a plan. We can make a plan. Um, I don't think I have question papers. Okay, we can do the questions what Bradley sent us. We can do those. So where was I now? Yeah, number 9. So square root 2, it cannot simplify anymore. So our radius will be square root 2. So we plot square root 2 all the way around. Negative square root 2, negative square root 2, positive square root 2. Then we draw a nice circle. This isn't a nice circle, but you draw a nice circle. That's a neat one. Okay. So this next one, number 10. Number 10, we are given 2x squared plus 2y squared equals to 8. Now, this isn't our standard formula of a circle. So we divide 2 across because we can. Then we left with x squared plus y squared equals to 4. Then what do you do? We say square root 4 is 2 equal to 2, right? Equal to 2. Then we plot our 2. We plot our negative 2. Our negative 2 and our positive 2. So we draw a nice circle. Very straightforward, right? Number 11, the very same thing. X squared over 3 and y squared over 3 equal to 1. They tend to confuse you here with this one because you would think intercept form, alright? But wrong. Intercept form, intercept form, it's for a straight line. Our intercept form is a straight line because we go from standard form of a straight line to intercept form. So yeah, so this is our standard form of a straight line, right? And this is intercept form. So we don't get confused. Where's the other one now that I saw? Yeah, this is intercept form because there's no squared and there's no squared over there. They're gonna confuse you, yeah? Thinking, see even the one is also there for intercept form. The one that confuse you, so you can maybe catch on nonsense here and say y equal to something and then have a whole funny thing. But this is still circle formula because x squared and y squared, that should just give you the hint that it's a circle, not a straight line. Okay? So we do the same thing again. We multiply with the 3 to get rid of this fraction 3 over here. So yeah, let us say it like this. Multiply by 3. Here we divided by 2. So here we multiply with 3. That's how we have 3 over here now. And all we do, like the others, we say square root 3. Square root 3 can't be simplified anymore. So that's our radius from the center. So all we do now, we plot our square root 3 there, our negative square root 3 over there, our negative square root 3, our positive square root 3. Then we draw a circle. Nice and straightforward, yeah? Next one. This next one is actually a half circle. And what I want you to pay attention to is just x. It's saying x equals to square root 16 minus y squared. Very easy to plot and draw also. All we do, we say square root of 16. Forget about that there's a square root there and there's a minus y squared there. Forget about that. That does not matter for now. We look at the number inside. The number is 16, so we say square root 16 is 4, right? So what we do, we plot 4, we plot our 4, we plot our 4, or negative 4 over there, right? From the origin. So here we have positive. It's a positive square root 16 minus y squared. It's a positive, right? It's a positive. That is why we have this on the positive side of the x-axis. Can everybody see that? It's positive side because it's positive over there, right? Number 13. Okay, let me say it like this, okay? So this is x equals, right? That means that our half circle will always cut through the x-axis. Always. This is y equals our half circle when it's with respect of y will always cut through the y-axis depending on if it's positive or negative. Just to make a differentiation so you know at least which way the half is going. If it's x-axis, it is passing through the x-axis. If it was negative, it would go this way, passing through the x-axis. But yet it's passing through the positive side of the x-axis. Okay. So again, very same thing. We look, here we have y equals to negative square root 7 minus x squared. We don't look at the, we don't look at anything else first. The first thing you look at is the number. And the number is a 7, so we say square root 7. Square root 7 can't be simplified more, so it's a square root 7. So we plot our square root 7 from the origin, right? Then we look with respect to y to the y-axis. This graph it's negative, so it's going to be on the negative side of our y-axis. Very straightforward, right? So number 14. Now 14 is saying y equals to 16 over 9 minus x squared. So, 1 second, let me just do this thing. Oh, that's worse now, eh? Is it any better now? No? Let me see. Okay, let me do a thing. Okay, they're gonna cut us off now anyway. They're gonna cut us off soon, quickly before they kick us out. Okay, so we're the same thing, right? Look at the number, and it's with respect to the y-axis now, eh? So we know that the graph is gonna pass through the y-axis. And okay, so we look at the number first. It's a 16 over 9. So square root 16 over 9 is 4 over 3. 4 over 3. So we plot our 4 over 3, and it's gonna be in the positive side of our y-axis. So it's gonna be on top. On top. So we plot our negative 4s over 3, our positive 4 over 3, and our positive 4 over 3. Now we said square root 16 over 9. Square root 16 over 9, it's 4 over 3. Yeah, let me see. Is what we get. Okay, so that's number 16, and it's number 11, right? What I wanted to see is it looks quite similar to each other, right? But the numbers are different. This one we can simplify because they are the same number. Not simplify, but we can get to the standard form of a circle. We can get x squared alone and y squared alone. That's all we need to make the equation of a circle. But number 16, we can't do that no matter what we do to this thing. It will never give us x squared alone and y squared alone. Therefore, it is an ellipse. Same with number 15. No matter what we do to this, we'll never get x squared and y squared alone to make our standard formula of a circle. Therefore, it has to be an ellipse. So, how do we plot this thing? Very straightforward. Very, very straightforward. So, we start with number 15. So, what we do is, all we do, we see for the x-intercept. No, wait one second. For the x-intercept, I think I made a mistake maybe on one of my things. Okay, we start number 16. Number 16, we look at the the number 4, and all we do is we we square root this 4. So we're gonna get a 2, right? So we have 2. A 2 there as a negative 2, and here we have a positive 2. For the y, and the x. For the y, we look at the 25, we square the 25. Then we get a positive 5 over here. And then here we get a negative 5. A negative 5. Then we draw draw our ellipse like that. Does anyone know how we do number 15? Guessing is good. Guess the factors. No, 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 no. We don't do that. We don't do that. No, I don't know how I forgot this thing now. Because my book is telling me one thing. My book is telling me, okay, you can't see now. You can't see this thing with the pencil. But what it is saying is, we square root, we start square root the 4, and we square root the 9. No, the 36, we don't do anything by. We don't do anything by the 36. But what it is saying is that we square root this 9, it gives us a positive 3 and a negative 3. Basically, a 3. It gives us a 3. So, but we plot that 3 on our x-axis. And then square root 4 is a 2, so we get a positive 2 and a negative 2, yeah. Let me draw. Let me draw a graph. As you can see, you square root everywhere. From 8 to 16, you square root everything. Yeah, that would be nice. But I haven't really seen. Okay, yeah, this I've seen quite a few things. Yeah, quite a few I've seen with this. But for tests, I rarely see this. For test one, test two, it's been a while since I've seen this asked actually. But okay, um, this is our ellipse. X minus 3, y minus. Oh, yeah, I think that's because this number 16. I don't want to say it's in the intercept form. I don't want to say that, but because of the form it's in, because of the form it's in, I think that plays a big role from the form it's in. If it's in a fraction like this 4 goes with the x. So square root 4 is a 2 and a 2. So on the x-axis, it will get that 2. 25 is what the y squared in a fraction. So they'll get that 5 on the y-axis. But because this isn't in a fraction, and we have this number with the radius maybe, but this don't matter. This number don't matter. But because there's no fraction, this square root 4 will go with the y, this square root 9 will go with the x squared. How fun. It seems like it's number 15 and a factor. or a fraction. But you see, um, I would say that number 16 works very similar to the intercept formula. You can remember the intercept formula, ne? Over here. 3 is for the x in a fraction. We plot the 3 directly as it is. The 4 is for the y in a fraction. So we plot it with the y on the y-axis directly. We do the very same thing over here. 4 is for the x squared. So we square root of 4 and gets it. And then the 2 is distributed on the x-axis. 25 with the y squared in a fraction. And we give it on the y-axis. So to me, it's similar. Not the same thing, it's similar. Okay, cool. Uh, okay, so this next one is, yeah, okay. Is everybody okay with this? I will try my best. When we do revision, right, on Sunday, when we do revision on Sunday, I'm going to, we can do a bunch of these examples. If it is in your test, right, and I didn't see it. Yeah, see, I didn't see circles in the test. No, I don't see any. Don't think I'm supposed to say that, maybe. But it's fine, man. Yeah, I didn't see this. But revision for your test, right? On Sunday. If you don't see me do this, we don't worry about it. Alright? We don't worry about it. But don't now say this in the group, man. Don't say in the group all this. Don't worry. So you don't see this in the on Sunday, don't worry about it for the test. We worry about this after the test where we do um depending now if they're gonna keep differentiation in, then we're gonna do differentiation after the test, then we're gonna do revision after revision after revision. We're gonna pack that work in. So we're gonna do some hundreds of this. I'm, I'm gonna say hundreds, but you're gonna do hundreds and we're gonna work nice. Okay. For now it isn't your test, but it's not supposed to be there because you're not following last trimester's plan. I don't know why they did it like that. It wasn't supposed to be like that. Yeah. So differentiation, right? Yeah. For now, it is just yeah, first principles and differentiation of like an equation. But differentiation, like it actually goes very far. It goes very very far. Well, I don't think for M3, but differentiation goes very 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 far. Yo, crazy how far it goes. So differentiation, like you see it till N6 almost. Actually in N6, if you can do N6 maths. So in N from N4, things step up again in differentiation and other things. But from N5 and N6, it's mainly differentiation and integration. Mainly, mainly that thing. But it can be nice. Yeah. So this one is your exponential graphs. So this one, yo guys, this is so easy also. Very, very easy. So this is to the power of x, right? All you do, again, You find one, it's positive, it's a positive exponent. We draw a graph like that. Finished. And this is a 1 actually. It's a 1. That point there, it's 1 on the y-axis. It's a 1. Nothing at all. The only time the number comes in play is for this one over here. If they say 3, if they say e to the power of x. If I say e to the power of x, then you find 3, then you plot the 3. If they say this, then you plot the 3 and it's positive exponent, there's a positive number there. So the graph is gonna continue like that. Okay. For 2 to the power negative 2x, or to the power negative x. So it's negative x, so we're gonna be on the negative side of the y-axis, but we're still gonna plot the 1. It's 1 still. So it's very same like this, just flipped around. So this graph is going up and it's on the positive side of the y-axis. This one is going to point down and it's on the negative side of the x-axis. Okay, now number 4, I think I did it wrong now. I think I mixed it up. Yeah, yeah, I know I mixed it up now. This, yeah, I mixed it up. My bad, my bad. We are all tired now. It's negative 2. Yeah, there's negative 2. The negative 2 puts it in the negative side of the graph. Am I right? Yeah. Yes. Yeah, number 3. Yeah, it comes away. It comes away. Yeah, I mixed the 2 up now. Yeah, but yeah, the graph is like this. It's negative 2. It comes at the bottom of the graph. So it's the opposite of this one, eh? It's still the opposite. So number 4 is going to be when the exponent is negative. When the exponent is negative, but the number it's positive. It's positive, it's gonna be on top. The 1 is gonna be on top. When the number is positive, when the number is positive, we're gonna be on the positive side of the graph. When the number is negative, we're gonna be on the negative side of the graph. Okay? So here it's positive, the number is positive, so it's on the positive side of the graph, but our exponent is negative. So if the positive exponent goes this way, the negative exponent will go that way. For number 5, we have a negative number and a negative exponent. So we do it in a we know now the number don't matter, né? It's always gonna be 1. So it's a negative number, so we're in the negative side of the graph. So it's negative 1. If the positive graph, well, if the positive exponent goes like this on the negative graph, the negative exponent is yeah, it's going this way. It's gonna go that way. It's gonna go opposite. It's just that that the orientation of it, that's how that could be the confusing part. But you just do it in a slow process, man. You do it in a slow process. Negative number, negative part of the graph, negative exponent is going to be that way. If the exponent is positive, it's gonna go that way. What you can maybe see is that negative exponent, okay, it all makes sense, positive number, positive side of the graph, negative number, negative side of the graph. That makes sense, but for the exponent, how can we differentiate for the exponent? Ah, hmm, yeah, I see what you're saying. I see what you're saying. Yeah, yeah, we can say that. Hmm, yeah, I agree with that. Yeah, I agree. For this log one, it's quite similar, but I will get more questions on this log one actually. I will get more questions on this log one. For log graphs, we find one again. I don't know why they love one. They love the number one. But that's all it is. I think a negative log would be this way, would be that way. But I will get more questions on this. But again, I've never seen them ask log questions like this. Never. So I think it's safe to say that all the work we're doing tonight, you won't see. I don't know, but they can ask anything. That's why we must do everything, man. That's the thing. That's the only thing. But let's move quickly. Um, for now, just try and get familiar with this. That's all. This next one is cubic graphs. That's one also very easy. Cubic graphs. I have three examples here. So y equals x plus 3, x minus 2, x minus 4. Number 2 is saying y equals x. Number 3, x plus 1, x minus 2 squared. Okay. Those graphs can be quite funny. Hoppa. And that's my phone dying. Okay. So y and the x, y and the x. Okay. So for those graphs, the first thing we must know is x plus 3, x minus 2, x minus 4. What is those numbers? Who can remember? What are these basically? What are these? Does anyone know what that is? Yes, it is points. Yes, that is correct. But okay, yeah. But what point is that? Yes. What else can we call them? Before it becomes x coordinates when you say x equal x plus 3 equal to 0, ne? And you took the 3 over, then it's a coordinate. But as it is now sitting here, what do we call this in brackets? Yes. So it's from that factored remainder theorem. When you look at when you look at that work, you must also see this now from now. Okay, we know that. So x plus 3 take it over x equals negative 3. Ne? We know this. So we plot our negative 3. X minus 2 equals 0 equals positive 2. So it's going to be a positive 2 over there. This is a positive 4. X minus 4 equals to 0. It's a positive 4. So this graph, it's positive. It is positive because there is no negative in front here. So this graph, right? A positive graph goes like that. A positive graph goes like that. A negative graph goes like this. Yeah. This is like if you know anything about sine waves, it starts like that, man. It starts like that. But okay, it never is like a perfect curves like that anyway. But okay, so as you can see, ne, this graph, no matter where it's gonna go or how it's gonna go, it's gonna pass through our y-axis. And we know that any point passing the y-axis is called the y-intercept. The y-intercept, ne? So to get the y-intercept, what we must do is we're gonna say this is a green pen. This this sign or this number, this can be maybe a two or a negative or something, but for now it's an imaginary one that stands here and it's a positive. So this number multiplied with that 3 multiplied with this negative 2 multiplied with that negative 4 will give us our y-intercept. So positive 1 times 3 is a 3. 3 times negative 2 is negative 6. Negative 6 times negative 4 is positive 24. So, so we mark here our 24. So now, now you must know it's a 1. You must know it's a 1 because it's the very same thing, ne? It's the very same thing as when we say x squared plus 2x plus 3. It's the same, ne? You know for a fact, or we're supposed to know by now, that there's a 1 there actually. If you say x plus x, here's an imaginary 1x there, and an imaginary 1x there to give us 2x. It's the very same thing. Like here, it's a negative, but it's actually a 1 that's there. Like even by this x cube here, there's a 1 there. Just can't see it, but it is there. But okay, it's basically saying there's one x to the power of 3 that's in this equation for now. But okay, so now we have this point here, and it's a positive graph. So we now draw our graph in. So this graph must now dip over here. So don't want the dip too much or too funny or anything, because the dip don't matter when you're drawing. For now, so there you complete. There you are complete. For number 2, we must now factorize this. So we're gonna take a common factor out, which is the x. We say x squared minus 9. So x squared minus 9 is difference of two squares. So it's going to be x plus 3, x minus 3. Okay. Again, we must say, basically, put x equal to 0. So x equal to 0, it is 0. That's the origin. X minus 3, x plus 3 equals 0. It's minus 3. X minus 3 equals 0 is a positive 3. Now, this special graph, not very special, but it's special, has no y-intercept. And it's a positive because there's a positive there. There's no negative. So it's a positive graph. So how it looks like this. It's actually, it extends further because it's a graph, right, on a Cartesian plane. So this graph goes forever, in the direction it's going, it goes forever. That's all it does. That's all it looks like because of this here. The x equals 0 here puts the graph straight in the middle. It passes through the origin. That's why there's no y-intercept. For this graph over here, number 3, we get our, sorry, no, you see, because here there is 3x values, here it's only 2, so this one is also, it's like a special one also, but you will see now why. So this is a negative graph, right? Because there's a negative over there, a negative, this here is a positive, this here is a positive. So, so. Okay. So what we do is we can write this one out, and then we're gonna say minus x plus 1. Then that's x minus 2, x minus 2. Alright? If we expand this one here, but we can get the same points. So x plus 1 equals 0. It's negative 1. It's a negative 1. It's a negative 1. X minus 2 equals 0. It's a positive 2. Let's put it like there. Put it like there. X minus 2 equals 0. That very same point, because it's the same point. Same point. Now, when the points are like this on either side of the y-axis, it's going to pass through. If there's 2 points like this, if the point doesn't pass through the origin, it's going to pass through the y-axis. Yeah? That's a rule to remember. If the x coordinates don't fall on the origin, it's going to pass through the y-axis, so we're going to have a y-intercept. So to get the y-intercept, what will our y-intercept be? Can someone tell me? looking at those equations here. Nope. Yes, correct. Minus 4. So we take this minus 1. Minus 1 times positive 1 is a positive 1. Minus 1 times positive 1 is negative 1. Negative 1 times negative 2 is positive 2. Positive 2 times negative 2, negative 4. So we have negative 4 there. So if you remember this, our negative graph, it starts from the top like this. It takes a curve under and then it curves down again, up and under. Okay, so we draw it like this. It's gonna come down, it's gonna pass through our y-intercept. Now, because this is the same point and it's a squared over there, right? This graph is gonna do this funny thing here. It's gonna do that. Only because it has two coordinates that's on the same point because of the squared. It's going to do that on that coordinate. It's going to turn other way. I hope you guys can see how straightforward these graphs can be. Like it's, yeah. Oh, what am I saying? I'm saying I hope you guys can see how easy these graphs can be, man. Like it can be. I know like it's a lot right now because it's brand new, but it can be very nice. And I really hope that we're gonna work nice after the test so we can make all this easy with enough practice. It's just because it's difficult now because we are pressed for time and it's new and it's a lot and overwhelming all these things. Yeah, I understand. But I really hope after the test we can put that work nicely in and practice a lot more. A lot more. So so for me, ne? Okay, okay. So we have x plus 3, x minus 3. So when you this has to have been in our previous math questions. We get factors like this, and they ask to solve x, and we get factors and they look like this because we took a common factor out of x. When you solve x, you're gonna get x equal to 0, right? As your x1. You're gonna get x equal to negative 3 as your x2. You're gonna get x equal to positive 3 as your x3. At some point, you had to have seen or done this in previous questions of the maths we've been doing. No doubt you had to have done it at least once. So all I'm yeah, so all I'm doing, I am solving for x. That's all you're doing. You solve x because like we said, this is your factors, right? This is factors. This is your factors. Also, your x coordinates. when you solve for x, it becomes your x coordinates or your roots. They call it your roots also. So that's where you get it from. 0 at the origin, -3, +3. Very same thing here. Very, very same thing. You solve x, it's all you do, you solve for x. First, you plot your points. You see, if it isn't going through the origin, if it isn't going through x equal to 0, you must get the y-intercept, and you get the y-intercept by doing this jumping here. By doing this jumping here, negative, the 1, the -2, the -2. The +1 here times the +3 times the -2 times the -4. Maybe I must add this. Um, yeah, I'm gonna put here y-intercept, y-intercept. Circle that. Put there y-intercept. I'm gonna put here y-intercept. Gonna circle that there. Then say that is our y-intercept. This over here is our origin. So we can have a rule. A rule for this, we can say if there's no x coordinate on the origin, find y-intercept. Yeah, we can say we can add by doing the jumps. Yeah, and that is your graphs finished. Finished. We will work through more examples as we carry on. Definitely for after the test, we finish all the work, then I will try to compile just questions of specific maybe question that I think is difficult or nice to work through, and then we can work nicely. Anyone have any questions at all? Yeah. No. Oh yeah. Oh, Friday. Yeah. Yeah, we can do it. We can do it. 6 to 8 again. Um, that is gonna be revision also. Yeah, we can do revision also. We can start our revision of the test. Or let us say this rather. Um, yeah, I can't. I know if I say okay, the work is now finished now, so we can talk now. I can just end the recording so it doesn't go too far.